Hi, everyone. Welcome to Managing Amazon RDS Databases with Kubernetes. My name is Jonathan Katz. I'm a Principal Product Manager Technical at Amazon, and I'm happy to be co-presenting with Chirag Dave, who I will let him introduce himself.
Hello, everyone. My name is Chirag Dave. I'm a Senior Database Specialist SA, specializing in RDS and Aurora. And I also work very closely for the product team on ACK. And that's what we're going to talk about today. So we'll get started.
So first, we're going to begin with a presentation where I talk a little bit about Kubernetes, running databases in and around Kubernetes, and AWS controllers through Kubernetes, which is an open source project that helps you manage your AWS resources directly from the Kubernetes API. After that, Chirag is going to demo the ACK controller for RDS, and then we'll recap it and talk about future direction. So first, let's start with an overview of Kubernetes. What is Kubernetes? Well, it's an open source project for container orchestration. So the next question is, what is container orchestration? A container is a sandbox process that restricts the environment in which certain things can happen inside that process. And what Kubernetes provides is a layer on top of that where you can create a unified operating environment for where these processes run, regardless of infrastructure. I like to think of Kubernetes as a distributed operating system that lets you control where you can run your workloads independent of the hardware layer underneath it. In other words, it's actually a standardized set of APIs for managing applications, regardless of where you're deploying those applications. For example, Amazon EKS provides a way to deploy Kubernetes across AWS infrastructure and easily manage it from the variety of tools that we make available to do so. One reason why Kubernetes is easy to use is that it provides a declarative approach for managing applications. What do I mean by declarative? So let's say I want to deploy a web application, and say I need 3 instances of it. I want to make sure it's deployed across my topology in a way where it's redundant. So if one node goes down, my application itself doesn't go down. There are a few ways I could do this. The imperative way would be to say, hey, deploy application 1 to node 1, application 2 to node 2, application 3 to node 3. Or I can do it in a declarative way, which I say, please deploy 3 instances of this application and make sure they're all deployed to different nodes. Notice the difference. In the imperative way, I have to go step by step through how I want to deploy my application. For the declarative way, I just say, here's what I want everything to look like, and things get deployed in that way. There have been different methodologies put in place to help with declarative management, GitOps being one of them. The principle of GitOps is that using a version management control system like Git, I'm able to know the exact state of what I want my infrastructure to look like and be able to go forward and back in time as I continue to build upon that infrastructure or roll back based upon some change that occurs in my environment. Kubernetes is also extensible, that while there's a lot of built-in primitives that help you manage things like your stateless applications, storing some things to disk, it allows you to extend it to capture further complexity and provides a declarative way of managing all sorts of resources, which we're going to talk about as we proceed through this talk. So let's talk about running databases on Kubernetes. This is an area I'm actually personally very passionate about. Kubernetes does provide a bunch of primitives that can be used to automate data management, from things like persistent volume classes, to storage drivers that use the CSI interface. There are all these tools that make it possible to store data and manage it with Kubernetes. As your applications get more complex, or you need to use a more complex type of application like a database to manage data, you often need to build in customizations that might not exist in Kubernetes. Kubernetes was fundamentally built around stateless applications, or processes that you can bring up and bring down and you don't need to remember anything about what happened with them. But when you get to managing state, or as I like to say, saving data, storing data, etc., you might need a little bit more information about how to do that. Let's take a relational database. In a relational database, there's a certain kind of operation called a point-in-time recovery, where you might want to be able to roll back to a certain point in time, based upon a change that was introduced, and be able to revert to that change. Different relational databases have different ways of handling a point-in-time recovery. For instance, Postgres might have one way of doing it, MySQL has another way of doing it. In order to capture all of these different complexities, you need to build custom tooling in order to be able to do this within a Kubernetes environment. And this is where the operator pattern comes in. An operator helps you program the different lifecycle management techniques that each of these data storage systems may have. Some of these operators are very sophisticated and can help create a managed service-like experience with running a database directly on Kubernetes. Let's note that as we go through this, that there are different requirements between development and production workloads when you're running any application on Kubernetes, or just any application in general, against a database. For instance, in a development database, it might be a bit more ephemeral, where I can just bring my data up, do some work, and then destroy it, and that's fine. But you're probably not doing that in a production environment. In a production environment, you need things like high availability, the ability to have disaster recovery in place, monitoring, and so forth. And there are you have to build in a lot of these requirements as you build out your applications. That said, a lot of these Kubernetes operators do employ the features that you need for development production workloads, and they can create that managed service-like experience that you see with Amazon RDS. However, what happens when things go wrong? When you need to troubleshoot something that's going wrong in your tech stack, where's the problem? If you're running your database directly on Kubernetes, you might have a few things to look into. It could be a problem in your application or within something in the database. It could be the Kubernetes operator you're using, maybe something in the networking storage layer. Maybe there's something in Kubernetes itself that you need to troubleshoot, or in the infrastructure itself, etc. So while Kubernetes operators do allow you to do some very sophisticated things with running database workloads on Kubernetes, there are many things to consider, during the production runtime of these environments that could lead to further expanding the surface area of what you need to troubleshoot. This is where AWS Controllers for Kubernetes, or ACK, can give you a managed database like Amazon RDS directly within your Kubernetes environment. What is AWS Controllers for Kubernetes? It's an open source project that lets you manage AWS services directly from the Kubernetes API. What this is it's actually a collection of Kubernetes controllers. If you will, you can call them operators. Controllers are the fundamental unit of an operator that interact directly with AWS APIs to provide that declarative management experience for your AWS services. So effectively, ACK is extending the Kubernetes API and letting you interact with AWS services the same way that you'd interact with something like a Kubernetes deployment or a Kubernetes stateful set. You get that declarative management experience where you can say, I want an Amazon RDS database with this engine, with this instance type, and with this much storage. Put that into your typical Kubernetes YAML manifest, upload it to the API, and ACK will deploy that Amazon RDS database to match that specification. There's all sorts of controllers for different AWS services, including Amazon EC2, Amazon S3, Amazon RDS, Amazon SageMaker, Amazon DynamoDB, Amazon Elasticache, and more. You can see the full list of the controllers that are available from the ACK documentation at the link provided in this presentation. You can also check out the entire project. It is a series of controllers. They're all open source. You can actually contribute to the project today if you want to be able to help out with writing the documentation or contributing a new feature. So let's provide some general overview around how ACK works. Each AWS service has its own controller. So Amazon RDS has its own controller, which we're going to talk about in greater detail. Amazon EC2 has its own controller. And these controllers can cover a lot of different functionality within that service. But the idea is that each of these services has its own controller, so it allows you to customize how you want your users to interact with it. Each controller uses something called IAM roles for service accounts, or I like to say URSA, and allows you to scope user access to least privilege for an AWS service. So if you're okay giving full admin privileges for an AWS service by default to your users, that's great. You can also scope it down. So say with Amazon RDS, you may only want your users to deploy certain instance types from a certain engine, and using URSA, you can ensure that that's what they can do when they're using the ACK for RDS controller. You can also dynamically retrieve info from a service resource, such as an Amazon RDS database host, and inject it into an application. This is through using something called a field export. For example, when I provision an Amazon RDS database, I don't know my host immediately upon provisioning. This occurs as part of Amazon RDS's provisioning process. Once that host name is available within the status, you can set up a field export to extract that host information and dynamically inject it into your pod. This allows you to use the ACK for RDS controller in a GitOps methodology. So that way you can declare all of your configuration, upload it to Kubernetes, and then set and forget, so to speak. So that way, as each resource becomes available, it's able to pass the information on to the next step, and your application will ultimately come online. You can also adopt existing AWS resources and manage them declaratively from ACK. This is through something called an adopted resource, where you can define the identifier for that resource with an ACK. ACK will go out and find that resource and copy it into an ACK custom resource, and then you can continue managing it from there. There's also options available to manage and deploy things in a cross-region and cross-account way. So let's see how ACK works. Let's say I want to create an S3 bucket using the ACK S3 controller. After I deploy my ACK S3 controller, the first thing I would do is write a manifest specifying my S3 bucket, how I want it to look, what its name is, etc. I then upload that to Kubernetes. It gets stored within etcd. And what happens is the ACK controller will get an event saying that a new S3 bucket resource has been created. Once it gets that event, it tries to reconcile it with AWS itself. It basically makes requests against the AWS S3 API to try to create the bucket. And once that bucket is created, it will update its status to indicate that it's created and pass that information back along to the user through the status field that's available. Now, a bunch of this occurs asynchronously, and if you want to be able to dynamically get the S3 bucket information for your Kubernetes application, you can use the field export resource that I had described earlier as a way to dynamically, look at when the S3 bucket request completes, and then be able to let your application know that it's available to use. So let's talk specifically about ACK for Amazon RDS. The ACK for Amazon RDS controller lets you manage Amazon RDS and Amazon Aurora databases directly from Kubernetes. And as I mentioned, this allows you to connect applications to your data following GitOps best practices. So this is giving you a managed database that is being managed by Amazon RDS, but makes it available to your Kubernetes applications. Additionally, if you're using Kubernetes as your control plane to manage your various AWS services, you can use the ACK for RDS controller to be able to manage your Amazon RDS databases. ACK for Amazon RDS is open source and is generally available in Q3 2022. There's several tutorials that can help you get started with the ACK for Amazon RDS controller. And you can also track the open source project as well. We're also going to do a demo in a few slides that shows you exactly how to deploy the ACK for Amazon RDS controller and some examples walking through how it works. What are some features of the ACK for Amazon RDS controller? First, it supports all of the relational database engines on Amazon RDS and Amazon Aurora. This includes Amazon RDS for Postgres, Amazon RDS for MySQL, Amazon RDS for MariaDB, Amazon RDS for Oracle, and Amazon RDS for SQL Server. It also supports Amazon Aurora MySQL compatible and Postgres compatible editions. In terms of the functionality, it gives you the full lifecycle management of what you would expect from an Amazon RDS database. You can create and provision new instances. You can manage them, scale them, add more replicas. You can adjust the resources, adjust the disk, and delete the instances. You can also manage the database replicas, add them, remove them as needed, and create clusters from snapshots, a workflow that's very important when you're doing something like test data management. It also supports Amazon Serverless V2 and Amazon RDS Proxy. So you have the full suite of Amazon RDS features available from ACK, and you can manage your Amazon RDS resources using declarative configuration via ACK. So here's an example architecture to help prime you in terms of how you could use it. Let's say I have an application that needs an Amazon RDS database and some caching. What I would do is I would deploy the Amazon RDS ACK controller and the Elasticache ACK controller to allow me to manage those resources directly from the Kubernetes API. I can then provision an Amazon RDS instance and Amazon Elasticache instance and inject that information into my application using using the field export resource. That way, I can connect my application living Kubernetes directly to these managed services in AWS. Let's do a demo. Let's see how we can use ACK to manage Amazon RDS databases directly in Kubernetes. Chirag, please take it away.
All right, let's go. Cloud9, where my kubectl is installed, and I will first verify if my Kubernetes cluster is accessible. So in order to do that, I'll run kubectl get nodes, and this is connecting to my EKS cluster. And this is where you can see that I have a couple of worker nodes where my EKS Kubernetes cluster is running. Now, for the demo purpose, I've already installed the ACK controller. So let's verify if my ACK controller is installed. And sure enough, I have actually two controllers installed. I have the RDS controller, and I also have the Elastic Cache controller. Now, if you're looking for instruction how to install controller, we do have a great documentation on our public websites, and also in some of the tutorials that we have posted, you'll find a step-by-step instruction of how do you go about installing it. And most recommended way is to install through Helm. And that's what I've done here as well. All right. Also, what I've done is I've created an RDS resource. In this case, it happens to be Aurora Postgres serverless instance. So you can see that you have a regional cluster, and within that you have a one writer instance is of type serverless v2. Those of you who are not familiar with serverless v2 is a new version of Aurora serverless, which provides you with the on-demand configuration of Aurora serverless. So it previews the on-demand capacity when you for your database application. Anytime you need more capacity, so database will grow and shrink between the number of ACU you have selected. So in this case, you see that 16 and 64. What does that apply is you have 16 as your minimum ACU and 64 as your max ACU. So your database will scale based on the workload between this range. I've already provisioned a Aurora Postgres database through the ACK, but that's no fun. So let's go ahead and create a brand new cluster. So I want to show you step-by-step how you go about creating a brand new cluster. And then we'll do in the second part, we'll show you how you can do that in an automatic GitOps pipeline. All right, so I'm going to refer back to my tutorial that I've posted, and the link is available in the PowerPoint slide that we presented. So what I'm going to do is I'm going to create a manifest. Again, what we're talking about is a declarative way of defining your database cluster. So in order to do that, I'll be using the exact same manifest that we have in our tutorials, where I'm creating a file called asv2dbcluster.yaml. So if you look at, pay attention here, is that the first one is a db cluster, where there's various definition or the specs for the particular engine. So in this case, I'm using Postgres, but again, you can certainly use MySQL, or this can be used for other services as Jonathan mentioned. And then once the cluster is created, we have another kind called DB instance, where I'll be selecting DB instance of a type serverless, and we'll be creating the cluster with one writer instance. So let's go and try and do it. So first, I'm going to define some of the variables, and once the variables are defined, I'm actually going to use the same code that's available on our tutorial. That's going to create a manifest for the my database here. So there we go. And I will do the same thing for the instance as well. Okay, so now let's go ahead and look at these two files real quick. So what do we have in the ASV2 cluster first, and then we'll look at the instance. So as you can see here that, again, we have a kind of DB cluster. I'm creating a sample DB. It's in certain DB subnet group. It's of Aurora Postgres. Again, like I said, if you want to change engine type to Aurora MySQL, you can certainly do that. I'm defining the engine version, happens to be 13, and my username and password is coming from the secret. All right, and let's look at the instance as well, real quick. So in the instance, you can see that of the instance class that I'm using is of type DB serverless, and it's going to be part of the cluster, which is the cluster name is sample DB. Okay, so let's go ahead and apply this change. Okay, here we go. And I'm going to first apply the cluster, obviously, and then the instance. So what is happening right now is that the controller picked up these manifests. It's going to start reconciling this with the RDS. So it's going to look at an RDS, do I have these resources? And obviously we don't. In this case, it'll start creating those resources. And if you want to find out, you can always look at, if you look at get pod in my DB, which is one of my namespace, ACK system namespace where my pods are running for RDS. And if you look at the logs for this particular pods, you would start to see that the reconciliation will be happening. It says I have new resources. I need to start creating new resources here. And there we go. You would see a bunch of messages. There's a lot of information flowing around here, but you can see here that the new DB cluster has been found and its desired state has changed and it's starting to create that resource. Let's go to our RDS console and see if this is actually true. And there you go. You can see that sample DB is running, or it is starting to create with the minimum and maximum ACU of 4 and 64, and that's what we have supplied in our manifest. So now we can see that you have defined your RDS resource as a YAML file now, and this YAML file then can be stored in a Git repository, which becomes your source of truth. So that's what we're going to do in the second part of our demo. So we'll let this cluster to be created, but what we'll do is I already have the first cluster, the ACKDB that you see in my Git repository, and I'll show you how we can apply changes in the Git repository to make changes to our RDS cluster. So let's go back to Cloud9, and when we go into Cloud9, I have my code commit repository checked out, and you see that I have a manifest called db.yaml, which is the one which is creating my first ACKDB. So let's go and take a look at it. And very similar to what you saw earlier with the sample DB. Now, assuming that you want to change any parameter in your cluster. So for example, I want to change my min capacity from 16, or I want to lower it down to, let's say, half ACU. You can go from half to 128, as I mentioned earlier. I want to lower it down. It's Friday. I don't need capacity that I need, so I lower it down. Again, you don't have to change your min capacity. But if you're not using it, if you need to lower it down, you can certainly do that manually. All right, so once I make that change, remember, this is a change, I'm pushing it to my Git repository, and I'll explain how the Git is talking to Kubernetes. So let me go ahead and make that change, and I'm just gonna commit to this change. So it's calling it changing min ACU. And let's go ahead and commit that, and I'm going to push that to my Git repository. Happens to be code commit. All right, now what's happening here is that in my Kubernetes cluster, what I have installed is Flux, and Flux is a tool in Kubernetes which is looking at my Git repository and trying to see if there's any new manifests being created. If it does, if it finds anything, it tries to reconcile with the Kubernetes. So now that we have changed my db.yaml, it will start to look and start to reconcile those changes. Now let's look at it here. Again, a lot of log here, but you want to pay the last line here, if you will, that it has detected some change. And now let's go back to our RDS console, and for our ACKDB, let's see if my ACU is changing from 16 to half or not. And we'll give it a couple seconds here, and we should be seeing that it picks up those changes. Okay. All right, now we can see that we can see the store artifact commit change min SEO has been picked up. Now let's go and look at it here. And there we go. We see this, the min ACU is reflected on your cluster. So again, what happened is now that your commit has been in Git now. It's a source of truth where you have defined your manifest. And once you change anything in the Git, it flows down to Kubernetes and down to RDS console or RDS on the RDS where your resources are running. Now, let's go and see how we can add a brand new database cluster if you want to create a database cluster. So what for the demo purpose, I've created a db-do-new.yaml, which is similar to db.yaml, where I'm defining the db cluster and the db instance. And I will let Kubernetes or my Flux to pick that up and start applying that change. So only thing I need to do is I have this customization.yaml, which is saying run resource called db.yaml. But now I need my db-new.yaml. So simply what I'll do is I will just add db-new.yaml and commit that change in the repository. What's in the db-new.yaml? Very similar to what you've seen earlier. Let's quickly look at it, what I have here. So again, what I'm doing is I am creating secret, I'm creating a DB cluster, I am creating a DB instance. Notice the only changes, this is called ACKDB01. I have a DB instance. And there's one other thing that I'm doing. I'm creating a config map, and I'm using one of the CRD called field export. So what this does and why it's important. Now, if you have a database, your application is going to be using, likely your application is going to be using this database. So application needs to know where to connect and how to connect and what are the credentials. So what you can do is once the resource gets created by ACK can then take those export of your endpoint, the port number, the username, and push it to a config map. And once you have this data in config map, you can then attach these config map to your pods, so your pod can then connect to the database, right? So in this case, I'm also creating some field export and a config map. All right. Now that I have made the change to customization, I'm going to go and commit that and call it adding new DB. And again, I'm doing through this Git pipeline. So I'm pushing this change, and what I'm going to be doing is going git push. And once I push this change, once it's in the repository, again, like I said, Flux should pick it up. And let's look at that. And what you expect here is that Flux will say, okay, I found the new manifest and new customize, which I need to make a change to. And it will start making the reconciliation, right? And once that happens, we can clearly go back to the RDS console and see if the ACKDB01 starts getting instantiated. So it takes a couple seconds here. If you remember earlier when we did the sample DB, that is still being created. It's all right. And we'll give it a couple of seconds for the manifest to pick up. Here we go. It picked up store artifact commit adding new DB. And at any point now the ACK controller should pick that up and start creating. And there we go. We can see that ACKDB01 starting to create. All right. So now again, to summarize, what we've seen here is that first we had an existing cluster. So we actually were able to change the parameter of a cluster. In this case, we changed the min ACU. We also looked at how you can create a brand new cluster, and more importantly, everything to a GitOps pipeline, right? In this case, like I said, we are using Flux, but there are other reconciliation tools available that you can use for your pipeline. Right. Again, thanks for watching, and if you have any question, happy to answer. Thank you.
So let's do a quick recap of the demo we just saw Chirag do. We saw how you can deploy and manage an Amazon Aurora Serverless V2 cluster using the ACK for RDS controller. We then saw how we could manage the database resources in a GitOps pipeline. And this gives you the benefit of having a managed relational database that can scale up and scale down with your workload and connect it to your applications that you're scaling within Kubernetes. So as I like to say, it's the best of all worlds. So what's up next for the ACK for Amazon RDS controller? We're going to continue integrating Amazon RDS API changes as new functionality becomes available. We're also going to be supporting new database services when they become available as well. This is an open source project, and we're trying to keep an open roadmap. So you can check this out directly on the project webpage. And of course, please leave suggestions for new functionality that you want. The beauty of open source is that you can have a direct say in terms of shaping the roadmap, and we can use that feedback to learn how we can better help manage your database workloads directly from Kubernetes. All right, let's summarize what we saw today. AWS Controls for Kubernetes lets you declaratively manage your AWS resources. So this can be Amazon EC2, Amazon S3, Amazon RDS, Amazon Elasticache, Amazon MemoryDB. ACK gives you the benefits of declarative management that you see from your native Kubernetes resources and applies it to AWS services. This lets you use AWS services in your GitOps pipelines. For example, you can use ACK to connect your Kubernetes applications declaratively to your Amazon RDS databases and get the fully managed database experience. You can even have your databases work similarly to your Kubernetes workloads with Amazon Aurora Serverless v2, where Serverless v2 scales your database capacity based upon your Kubernetes application workload. As I mentioned, this is open source. You can read the documentation online. You can actually contribute to the project as well and follow the open roadmap in terms of what's being developed for ACK. So with that, we thank you for joining us for the webinar today, and we're happy to answer any questions.